Contrastive predictive coding or CPC-based solutions that exploit the frame level structure in speech to learn representations. But the structure in speech exists beyond frame level. It exists at phoneme level, it exists at word level and beyond. In this work, we attempt to exploit not only the frame level structure, but the phoneme level structure to learn better representations or to do better downstreaming tasks. And how do we do that? We essentially put a boundary detector on top of a frame level feature extractor, and then we aggregate the boundaries that are generated or the segments that are generated by the boundary detector to get the segment level representations. And then we try to learn the segment level representations using the CPC loss at segment level. So if you look at the bottom of the architecture, it essentially is trying to focus at the frame level details or the frame level information. Or if we try to look at the top, the model or the architecture is essentially trying to focus at the segment level details, and the boundary detector is essentially the glue that connects the frame level information and the segment level representations. So, and to train this, we essentially combine both the frame level loss and the segment level loss, and we train it directly in an end-to-end manner from the waveform to segment level representations. And we use our segmental contrastive predictive coding or SCPC framework for unsupervised phoneme segmentation and unsupervised word segmentation. And we evaluated on TIMIT and Buckeye dataset. And as you can see, our model outperforms the existing methods on both the dataset. And if you look at the CPC plus sign, it's even more interesting. CPC plus is essentially the CPC model, but it's trained with additional data from LibreSpeech, and SCPC is able to outperform a model that has been trained with significantly higher amounts of data. And we performed the similar experiments on word segmentation on Buckeye. And as you can see, the SCPC-based model outperforms the existing word segmentation models, both neural and non-neural. And one other interesting thing is, since we are able to look at multi-levels of information from speech, a single model is outperforming the phoneme segmentation methods and word segmentation method, thus unifying the two problems with a common solution.